Hello students, I am Runali Kumbar from Krishna Mahavidyalay, Rethe Budru. Today we will study the topic sound from 11th science. We know that sound is basic way of communication in human as well as in animal. All the time, different types of sound are present around us, and these sounds reaches to our diaphragm of ear in the form of vibrations, that means in the form of waves, and we listen sound. So friends, let us start the topic sound.
Students, to study this topic, we use the PPTs related to this topic because due to this we get clear idea about each and every terms in this topic. Students, first we will see what is meant by a wave or the definition of a wave. Wave means an oscillatory disturbance traveling through a medium without change of form. Students, we have already studied that the meaning of an oscillatory disturbance. Oscillatory disturbance means that same type of disturbance repeats itself again and again. Students, here also you can see how oscillatory disturbance repeats itself again and again through the medium, and which is called as a wave. Students, this wave is also called as a progressive wave. And the definition of progressive wave is a wave which travels continuously along the same direction away from the point of disturbance without change of form. Students, meaning of above definition is that a wave which travels in forward direction and it goes away from the point of disturbance without change of form or without change of shape. Students, we see progressive wave in our daily life. For example, wave along a water surface. When stone is dropped on the water surface, then waves are created on the water surface, and these waves travel away from the point of disturbance in the form of vibrations without actual transfer of particles. Students, there are two types of progressive waves. One is transverse waves and second is longitudinal waves. Students, first we will see transverse wave. Students, we know that the word transverse means perpendicular. We can better understand this wave with the help of an example of a wave along the rope. When one end of the rope is fixed to the rigid support horizontally and the other end of the rope is moving in up and down direction, then transverse waves are produced along the rope. Students, in this wave, it is observed that particles of a rope vibrate in a vertical direction and wave propagate in a horizontal direction. That means direction of vibration of particles and direction of propagation of a wave are perpendicular to each other. Therefore, this type of a wave is called as a transverse wave. So the definition of transverse wave is a wave in which the direction of the vibration of particles is perpendicular to the direction of propagation of a wave, and the examples of the transverse waves are wave along a rope and light waves. Students, this is one more example of transverse wave. In this wave also, particles are vibrating in vertical direction and wave propagates in a horizontal direction. That means these two directions are perpendicular to each other. Therefore, this is an example of transverse wave. Students, we can learn more about the transverse wave. In this example of wave along a rope, we see different characteristics of transverse wave. Convex part of the transverse wave is called as a crust and concave part of the wave is called as a trough. And here also we can see what is meant by amplitude of a wave. Amplitude means it is the maximum displacement of the particle from its mean position. Then another term related to the wave is wavelength of a transverse wave. That means wavelength of a transverse wave is the distance between two successive crusts or the distance between two successive troughs. Students, next type of progressive wave is a longitudinal wave. Students, we know that the word longitudinal means parallel. For better understanding of longitudinal wave, we can consider an example of wave along a spring. When one end of the spring is fixed to the rigid support and other end is moved slightly in outward direction, then longitudinal waves are propagated along the spring. As shown in this PPT, students, here we can observe that particles of spring vibrate in a horizontal direction and wave also propagate in a horizontal direction. That means direction of vibration of particles and direction of propagation of a wave are parallel to each other. Therefore, this type of a wave is called as a longitudinal wave. So, the definition of longitudinal wave is a wave in which the direction of the vibration of particles is parallel to the direction of propagation of a wave. And the examples of longitudinal waves are wave along a spring and sound waves. Here we can see how sound is produced with the help of tuning fork. When one prong of tuning fork vibrates, then air layer near the prongs vibrates and these vibrations travels as a sound wave. That means in case of sound wave, direction of vibration of particles is parallel to the direction of propagation of a wave. Therefore, sound is an example of a longitudinal wave. This is another example of longitudinal wave, that is wave along a spring. As shown in figure, it consists of compressions and rarefactions. Compressions means it is the part of a medium in which particles are crowded together, and rarefaction means it is the part of medium in which particles are more separated from each other. And wavelength of longitudinal wave means it is the distance between two successive compressions or two successive rarefactions. So students, as we discussed here, sound waves are longitudinal waves. In next session, we will study the difference between transverse waves and longitudinal waves in more details. So students, thank you for watching this video.